let's talk about linear inequalities. We've talked about linear equations, things in the form of like y equals 3x plus 2. We've also talked about inequalities, x is greater than 4. Okay, now we're going to combine these two ideas. We're going to talk about linear inequalities. And linear inequalities have two variables, and instead of an equal sign, they have an inequality sign. For instance, y is greater than x minus 3 is an example of a linear inequality. Just like a linear equation, there isn't just one solution to this. There are many, infinitely many solutions to this. And it's easy to check if something's a solution. Let's say 1, 2. Let's say we're interested in seeing if this is a solution. Well, we simply plug in. 2 goes in for y is greater than 1 minus 3. 2 is greater than negative 2. That's true. So this would be a solution to this linear inequality. So now let's talk about graphing inequalities. Let's start with that same line. Y is greater than x minus 3. And I start by graphing y equals x minus 3. And I start at negative 3. And I have a slope of 1, so I go up 1 over 1, up 1 over 1, up 1 over 1, and I make this dashed line. And I make a dashed line because we are dealing with just greater than, okay? If we were instead dealing with y is greater than or equal to x minus 3, then I would do a continuous line. But we're not. We're dealing with y is just greater than negative 3, so we just leave it like that. Now we have to figure out which side to shade. I always start with the origin. If the line is not going directly through the origin, this one is not, I can use the origin and plug it in for my y and x. So I'm plugging in 0, 0 for y and x, and I'm solving. And I get 0 is greater than negative 3. Is 0 greater than negative 3? It is. That's a true inequality. So I can shade that side of the graph. And that's my finished graph for this inequality. If, however, I was dealing with y is less than x minus 3, and I plugged in the origin 0, 0, and I got 0 is less than negative 3, which is not true. Okay, that is not the case. I'm going to actually shade the other side of the line. And that's my completed inequality. But in this case, I am dealing with y is greater than, and so I shade it like this because the origin does work. Let's do another example. Y is less than or equal to negative 2x plus 3. I'm going to start out with positive 3. We have a slope of negative 2, so we go down 2 over 1, down 2 over 1. And this one is greater than or less than or equal to, so it's a solid line. Once again, notice we're not going through the origin, so we can use the origin. 0 is less than or equal to negative 2 times 0 plus 3. Negative 2 times 0 is 0, so 0 is less than 0 plus 3. 0 is less than or equal to 3. That's true. So because that's true, we can shade in this side of our graph.